Hi everyone. Today I'm going to show you how to find the center of a circle given 3 points on the circumference of the circle. As you can see in our chart here, I've got 3 individual points on the circumference of the circle. That's easy to see from our picture here that we've located the center point, but what would you do if you just had a circle or 3 points in space and you didn't see the circle and you wanted to find get rid of all of these, and you wanted to find the center. And that's all you had. So the first thing, or the first reason we need 3 points is because if you only had 2, say this red point and this orange point, a circle could curve down from the top and pass through both points, or it could curve down from the bottom and pass through both points. So we need this third one to really solidify our actual coordinates in space where this circle is going to pass through all 3 of these, and then we'll find the center. So if you haven't seen any of my previous videos, how to chart a circle, probably want to start with that just to see how I've created these first 4 columns here. It's the same way as I did in the first video. Degrees, I convert that to radians, and then I have my sine and cosine for each point on the circle, and then I plot the circle. What we're really going to do is start with our points up here. Here's point 1, that's our orange. Point 2, that's our red. And point 3, which is our green. The first thing we need to do to find the center of a circle made by these 3 dots is connect 2 of the points together to make a line. So we're going to make 2 lines actually. First thing I want to do is create a line between points 1 and 2, and then a line between points 2 and 3. The next step after that is to recognize that any 2 points on the circumference of a circle create that line, and the midpoint of that line at the slope of a tangent line to your original line, that line will pass through the center of the circle. So that's what we're going to do. We're going to find the tangent line slope, the midpoint, and then we're going to find the intersection of that exact same line, the tangent line to the midpoint of the opposite line, and we'll find it somewhere out here in space. So after finding the slope of each of these lines, which the first one is almost 0, it's negative 0.04, it's going slightly downhill. Line 2, 3 is going much more steeply downhill, negative 3.17. So the perpendicular slope is going to be 1 over the reciprocal of those slopes. So the perpendicular line is very steep in comparison to line 1, 2. It's a slope of 22.9. You'll see where I did negative 1 divided by my original slope. I did the same for line 2, 3, and I get a perpendicular slope of 0.315. Now that I've got those, we'll just keep them in our spreadsheet. Then we'll find the midpoint of each of these other 2 lines. And the way you do that is you sum up the x's of the 2 points in the line you're looking at, divide it by 2, and we'll find the mid x. And then you do the same for the y coordinate. Sum them, divide by 2, and that's the y. I also did that for the line 2, 3, x and y. So now I've basically got this midpoint here, this midpoint here, and I know where the slope is going to be. And with that information, I can then calculate the y-intercept of line 1, 2, and line 2, 3. And you'll see that equation up here. If you'd like to know more about how that it's actually calculated, I will go over that specifically if requested. And with that, I can then substitute my y-intercept and use my tangent line slope. I'm sorry, not substitute, but I will I will use my tangent line slopes and the y-intercepts, and I will set the equations in slope-intercept form equal to each other. So y equals mx plus b for both lines, therefore m1 x1 plus b1 equals m2 x2 plus b2. And when you solve for that for each, you'll end up getting your intersection point, which happens to be the center of the circle. In this case, it's 0, 0, and it should be, and that will change with me changing the origin up here as well. So I'll turn on some more points to make it a little easier to see this. We'll calculate a perpendicular line, point 1 for line 1, 2, and perpendicular line 2, 3, and their intersection point. I'm only plotting from the midpoint of the line that I calculated to the intersection point of the two lines. It's the center point created by that intersection. And then by knowing the center of the circle and by knowing the center point of the circle and the radius, you can calculate how your equation for your circle, which looks like that. And this is kind of a neat tool to allow you to move the points around the circle and see that this is always true, no matter where you move your points. This set of equations will always find the center of your circle, no matter where it's at in space. We can move it, and we'll move it around some more. And it doesn't matter where these points are, they can be anywhere. They can overlap out here. It has to be a true case. As you saw there, we had a divide by 0, so it's not going to correctly find it. So it's got to be 3 different points. You cannot have 3 points and any 2 of them be the same. They all have to be unique. But anyway, that's how you find the center point of a circle given 3 points on the circumference. So like my video, subscribe, or if you have any questions, leave a comment below, and I will do my best to answer any questions or make a video you'd like. Thank you.